Greetings to every one of you. So in this video we are going to discuss about another important algorithm in operating system, that is non-preemptive priority scheduling algorithm. This is a non-preemptive method of CPU scheduling that works based on the assigned priority values. Higher priority process will be executed first. So here we assume that greater the value and greater the priority. So the value is high and that particular process will be scheduled first. The non-preemptive priority, it means once a processor it is allocated to a process, the process won't be removed by the operating system forcibly on any account till its time of completion. So till the end of the burst time, the process remains in the processor. So that is the concept of non-preemptive. So let me explain this algorithm with the help of a given problem. So this is a problem with 5 processes, and all these processes have the different priority. Least priority is 5 and the highest priority is 20. Okay, but here the arrival time and burst times are given. We have to calculate the remaining things like completion time, turnaround time, waiting time, and its response time. Let us see how. So initially at time 0, the arrival time 0, we have only one process that is arrived. So that is the first process, that is P1. P1 arrived and its burst time, it is 4 milliseconds. So 0 to 4. Right. So during this period 0 to 4, we have to check any other process arrived during this time period. If you go through this, the arrival time, 2 processes arrived at time 1, that is P3 and P5. P3 and P5, they arrived at time 1. So similarly during time 2, at time 2, P2 arrived. Similarly at time 3, P4 arrived. So within this time period, all other processes entered the queue. They entered the queue within this 0 to 4. Now what you have to do, based on the priority value, the assigned priority value, we have to schedule the processes. Okay. So which process will be scheduled first? It depends upon the value of the assigned priority. Okay. So the value of this P5, which is the highest priority, you leave this one. So remaining among the 4 jobs, the highest priority value is P5. So P5 will be scheduled. So which require 3 milliseconds of burst time. So 4 plus 3, that is 7. P5 is over. The next priority goes to, that is P2, which has the value 15. Okay, and again its burst time is 8 milliseconds. So by 15, that is P2 is also over. The third highest value of the priority, it is P4, that is the value is 10. So P4 and its burst time, it is 2 milliseconds. So 17, at 17th millisecond, P4 is also over. The final one, that is P3, which require only, that is only 5 milliseconds of time. So 17 plus 5, that is 22. So with the help of this Gantt chart, we prepared the completion time, the chart which contained the completion time, the starting time and the completion time. Okay. So P3, completion time of P3, it is nothing but 22. Right. Then completion time of P4, it is 17. Then completion time of P2, it is 15. Completion time of P5, it is 7. And completion time of P1, it is 4. Now we got these values. So what you have to do? Now from this we have to calculate the turnaround time. So turnaround time can be calculated as it is nothing but completion time minus arrival time. So this is the completion time, arrival time 4 minus 0, 4. 15 minus 2, it is 13. This is 22 minus 1, it is 21. 17 minus 3, it is 14. 7 minus 1, it is 6. Now you have to calculate the waiting time. So waiting time can be calculated as turnaround time minus burst time. 4 minus 4, it is 0. 13 minus 8, it is 5. 21 minus 6, it is 16. 14 minus 2, it is 12. 6 minus 3, 3. Now find out this response time. So response time can be calculated from the starting time of the process minus the arrival time. So for P1 starting time is 0. So 0 minus 0, it is 0. Starting time of P5 is 4. 4 minus 1, it is 3. Similarly, starting time of P2, it is 7. 7 minus 2, it is 5. Starting time of P4, it is 15. 15 minus 3, it is 12. Similarly, starting time of P3, it is 17. 17 minus 1, it is 16. So this particular, the response time and waiting time, both are equal in the case of this non-preemptive scheduling. This already we discussed. Okay, even in the first come first serve, the shortest job first. In everything we discussed about this particular concept. Okay, so in case of non-preemptive scheduling, the waiting time is equal to the response time. Okay, from this table now we can calculate average turnaround time and average waiting time. So the average turnaround time can be calculated as I is equal to 1 to n. It is Ti divided by n. The total value it is 58 divided by the number of processes, that is n is the number of processes, that is 5. So which is equal to 11.6 milliseconds. Similarly, the waiting time, it is 36, can be written as the formula average waiting time can be written as sigma I is equal to 1 to n Wi divided by n. So it is 36 divided by 5, which is equal to, that is 7.2 milliseconds. So I hope you understood this concept, the non-preemptive priority scheduling algorithm, how to calculate the turnaround time of the given problem, and from which how to calculate the average turnaround time, average waiting time, and the response time. Both this response time and the waiting time, normally it is equal in case of non-preemptive algorithms. Thank you very much.